Charges are same. Charges are same, but they have a different polarity. Right? Polarity means that they have different kinds of charge. One is the positive one, the other one is the negative. Right? So then,
Yes.
yeah, so then we have to find out the uh, capacitance of this thing. Right? We need to find out the capacitance of. So we know that what is the capacitance? What is capacitance? Yes. What is capacitance? Archana,
Yes, sir.
what is capacitance? What is numerically how do we calculate capacitance?
Sir, charge by volt.
Right, Q5. Yes, absolutely correct. Good.
Yes, sir. Yes, Q.
So we have to Q is given, right? This we know. Voltage between the plates, that is what we have to find out. Right. This is we need to find out. So let us find the voltage and then we can calculate the capacitance. So before we do that, what are the things that we know about this parallel plate capacitor, right? So we know that, yeah, let me, yeah, to calculate the capacitance, we need this Q, we need this voltage, and this is we are trying to find out. So we have a parallel plate, right? And its area, we know. So we know the area of this thing, right? Area of this thing is, let's say this is a plate and its A. Area is A. Similarly, we have a same plate, but separated by a distance which is, so this one has a negative polarity. And this A has same area, right? And the separation between these two plates is D. This one has a charge plus Q, this one has a charge minus Q, right? So let's say the potential between these two plates is delta V, or let's say V. And we know that the uh, relation between the electric field and potential. What is the relation? We remember. So electric field was minus delta V by delta R, right? So let's say we are
Yes, sir.
taking the mod of it. So this would be delta V by delta R. And let's say the potential difference between these two plates is V. And the separation that is T. So E is how much? That is voltage by the distance between the plates, right? So to calculate the voltage, we will we need this electric field and this distance field. So to calculate the voltage, we require this electric field, right? Arshad?
Yes, sir.
So we need to calculate the electric field between the two. This is we need to calculate. So let us go back in the memory lane and yeah, this we will come at later. So let us go back in the memory lane. So we have, let's say, a plate. So this will have, right? Let's say this is a positive one. So what is the electric field of this plate? Do you remember what is the electric field of this thin sheet? How much is that? Yes.
Yes,
See,
sir.
in the first chapter, we talked about the electric field of thin sheet, right?
Yes,
We,
sir.
we used the Gauss law, and from the Gauss law, we found out the electric field of thin sheet. What was that?
The electric field of thin sheet.
This was,
Uh,
yeah,
electric field of thin sheet.
this was sigma by 2 epsilon naught, right? In this side, and this was sigma by 2 epsilon naught in this side. So this was the electric field. Do you remember it now?
Yes, sir.
And for the minus one, the electric field lines were in which direction? For the minus one, what was the direction of the electric? They were in this direction,
Yes,
right?
sir.
And the amount of electric field was C, right?
Hmm.
Okay, so now we have this thing. So we can see in here, right? Now let us use that idea. So I will write with a different color. So let's say that for positive ones, there are three regions, right? There are three regions. So one is this one. So in here, due to this one, we will have outward electric field, and that is sigma by 2 epsilon. Due to this one, in this region, also the field are going away from this point. So again, sigma by 2 epsilon. But in the left hand side, the field would be in this direction, right? So this is again sigma by 2 epsilon naught. Correct? So do we have any other regions? One is between the
Yes,
plate,
sir.
left
The
side, right side.
between.
We don't have any other regions, right?
Mhm.
Yeah. Now we have calculated the electric field of this plus Q1. Now let us write the electric field of minus Q1. So for minus Q1 in this region, the electric field would be in this direction, right? And how much would be this? This would be again sigma by 2 epsilon, right?
Yes.
And in here, in the right hand side, where would be the direction? Right side or left side? Minus, minus Q. What would be the direction? Left or right?
Sir, it will go both the directions because
I'm asking due to this minus Q,
uh,
this side, the electric field lines would be outgoing or incoming.
sir, outgoing.
This is minus, so that would be attractive, right? So incoming.
Oh, yes, yes. They'll go to
So
the opposite directions.
yeah, so we have just seen from here. For minus, this is incoming. For plus, this is outgoing, right? So for this plus, all the lines are outgoing from this side. For minus, all the lines in every side would be incoming.
Yes.
In here, where would be the direction? Left or right? Due to minus 1, minus q. What would be the direction? Left or right?
Sir, left.
Left is, so left one would seem that it is going away from this. Is
No,
it
sir,
not?
towards Q, right? Towards Q.
That would be this.
Yes, sir. Yes, sir. Towards Q, right?
Yeah, so this would be sigma by 2 epsilon. So the blue ones R4 minus Q, and this yellow ones R4 plus Q. So now you tell me that in which region. So you have first, second, and third. In what are the regions in which the electric field are cancelling out, and what is the region in which the electric field is adding? Yes.
Yes, sir. Can you just repeat the question? Sorry, sir. The internet here is, I think so. My Ethernet is not
Yeah.
connected properly. That's why, sir.
Yeah. So maybe, maybe yes. Okay. So I'm asking that there are three regions, right?
Yes, sir.
There are, and it may happen that in some region the positive and negative one are cancelling.
Yes, sir.
Electric field due to positive and negative, they are cancelling out. And in some region, they are adding. So I'm asking that in which region they are adding up and in which region they are cancelling out.
Sir, in the middle region, they're getting cancelled
Yes.
out.
In the middle, they are going in the same direction. So how can they cancel if they are going in the same direction? If you
Sorry,
are
I wasn't looking.
pulling this, yeah, if you are pulling this thing in this direction, some other guy is also pulling this thing in this direction only.
Yeah, yes, yes. I
So
wasn't looking properly, sir.
yeah. So then this will add up, right?
Yes, this will add up.
Second
So,
region add up.
so the first and third region will get cancelled out.
First and third cancel. So there would be no electric field outside the capacitor, right? So in second region, that is what we wanted to find. That was the goal. Electric field between the plates that we wanted to calculate, right? So then, yeah, so this is just right. So then we have what is the total amount of electric field? Sigma by 2 epsilon naught, sigma by 2 epsilon naught. They're adding up, right? So E total. Oh, I have written E, so I should write. Let's say all these are E1 and this is E2, right? So in the middle region, the total would be E1 plus E2, which is sigma by 2 epsilon naught plus sigma by 2 epsilon naught. So half of is 1. So this is 2 sigma by 2 epsilon naught, right? So sigma by 2 epsilon. This electric field is sigma by epsilon. This thing we have calculated, right? Now we know the electric field. And can you tell can you tell me what is this surface charge density? What is this yeah? How do we write surface charge density? What is surface charge density?
So, like the formula. Sir,
Yes. What is the formula for surface charge density?
so the formula for surface charge density will be uh, charge by the area.
Charge by area. Yes, that is correct. That is the surface charge density, right? So surface is charge is Q, surface is A, and density meaning the you are dividing it by area. Yeah, so that is correct. So if we put this value in here, so E would be how much? So sigma is Q by A epsilon. Right? So this is on, right? Now we have electric field. So then the idea was to calculate the voltage, right? We wanted to calculate the voltage. So that would be V is E. E we know that is Q by A epsilon naught and T. So V is Q D by A E epsilon. Right. Now you tell me that we have this voltage, we have this charge, right? So then we have both the things. Then we can calculate the capacitance. The capacitance would be how much? Capacitance is Q by V. Q is Q. V we have calculated D by AE epsilon. So this thing will go in the numerator. So capacitance would be how much? Q into AE epsilon naught by Q into T. So this thing will cancel and you will get AE epsilon naught by T. So you see from here that the capacitance is only dependent upon the geometry, area and the separation. It is not dependent upon the charge or the voltage, right? So this is the capacitance of the parallel plate capacitor. You please note it down, and if you have any doubt, please tell me.
Yes, sir.
Okay, so please note down from here, right? Yeah, whenever you want me to slow down, please tell me.
Yes, sir. Just a few moments, sir. Yes, sir, done.
Yeah. Then please, Tom, I'm just writing an email to my collaborator.
No such one.
Yeah, whenever you want me to scroll down, please tell me.
Yeah, yes, sir. Yes, sir. Just a few moments.
Oh,
Yes, sir, done. Yes, sir, done.
okay, so what did we understand that if we have a parallel plate capacitor, so the capacitance of that parallel plate capacitor would be this much, right? And it is depending upon the area and it is depending upon the distance. So can you tell me if we decrease the separation, so what will happen to the capacitance?
If we decrease the distance, I think so the capacitance will increase then.
Yeah, absolutely right. Good. And if we increase the area, then of course the capacitance will also increase, right? And you see
Yes,
that
sir.
this epsilon naught is there, which is telling us what? That it is also depending upon the medium, right? So if we put a medium, dielectric medium inside the capacitor, so that will also change the capacity, right? So we already know that how the capacitance change, how the uh, this permittivity changes if we insert a medium, right? So capacitance of a parallel plate capacitor with dielectric. Okay. So we have what? We have a dielectric, we have a capacitor, right? And it is represented. So parallel plate capacitor, what I told you earlier that it is represented by two parallel, right? This is
Yes, sir.
the capacitor, this one is positive, and this one is. And now what I am doing is that I am putting a dielectric slab in between the plates, right? So I am putting a slab between the plates. This is this partially filled or is it fully filled? How this dielectric is filled? Is this partially filled or fully filled? Yes,
Sir, it is fully filled.
it is fully filled, right? So write in the bracket that it is fully. Okay, so this K is what? This is dielectric constant, right? That K will. So if we know that how the electric field changes if we insert a medium. So earlier in air, the electric field was what? This was sigma by epsilon naught, right? So now the if I put a medium, then what would be the electric field? This would be sigma by epsilon, right? Yes.
Yes, sir.
So how this E and how this epsilon and how this epsilon naught is related? We remember. Yes, we remember the electric charges class. So this is related with the old one as epsilon naught into K. This E is epsilon naught into K, right? So if we put this value, so E medium would be how much? This would be sigma by epsilon naught is E air, and then this is K. So this is reduced by this K factor, right? So if we write the capacitance, I will not write. So this would be simply AE by D because epsilon naught changes to epsilon, right? And this is how much? So this is A epsilon naught K divided by D. So the new capacitance would be A epsilon naught K by D. Is this thing clear? This thing clear?
Yes, sir.
Confirm. Okay, so this is the capacitance. Now we will calculate the capacitance for a partially filled uh, capacitor, right? And with dielectric, right? So then this would be how much? So then your capacitance would be up. So what have we done? We have this parallel plate capacitor, and we are partially filling this capacitor with this lamp, right? So it is partially filled like right? So this is this one, and right. So let's say that thickness of this thing is T, right? So then what would be this separation? What would be this air part? Total distance is how much? Total distance is D, right?
Yes, it will be D minus T.
Yeah. So the separation without this dielectric would be T minus. Right. To calculate the capacitance, what did we calculate? So we calculated the voltage, right? We
Yes, sir.
calculated the voltage, and this was E into T, right? This was the voltage that we found out. Now you see that there are two things in here, right? So voltage would have two contributions. One would be from this one, the other would be from this right? So the voltage would be E air and D air plus this is E medium and D medium. Is this clear, Arsana?
Yes, sir.
It is not clear.
No, sir, it's clear.
Yeah. So we are just dividing voltage into parts, right? So one is this one and the other one is this. So V is V1 plus V2. That is what we are writing, right? Because you can see that this is a series combination. So in series combination, voltage is different. V1 plus V2. That is what we are writing it here. So you see that E air is how much? E air is sigma by epsilon naught, and yeah, that's it. And then distance air. Distance air is, as we have said, T minus T. Clear? Clear.
Yes, sir.
And what is E medium? Now you tell me what is E medium. Yes, what is E medium?
Yes, sir. Epsilon by, I mean, sigma by epsilon naught.
Not. We are medium, medium.
Yes, sir, sigma by epsilon.
Sigma by epsilon, which is epsilon naught K.
Yes, sir.
And distance medium is this thickness,
Yes, sir,
right?
into T.
So now if we take, what are the commons that we can take? Sigma by epsilon naught T minus T plus T by K. Here. So this is my voltage. Now we know that how can we calculate the capacitance? So this is Q by V. So Q by this sigma by epsilon naught T minus T plus T by K. And we know that again sigma is QA, right? Q by A. So we can put this epsilon naught in here. This is Q by A, T minus T plus T by K. So this Q and Q will cancel. This A will go upstairs. So capacitance would be A epsilon naught minus T plus T by K. Okay. So this is the capacitance when the capacitor is partially filled with dielectric medium, right? This is the capacitance, and the other thing is capacitance of a capacitor partially filled with conductor. Okay, so we have again capacitor, and it is partially filled with let me change. It is filled with conductor. Right, so this is a conductor, right? This is a conductor. And you tell me, inside the conductor, what is electric field? Inside the conductor, because for a conductor, all the charges reside on the surface. So inside, there is no charge, right? So if there is
Yes.
no charge inside, so electric field is zero inside the conductor, right? So then, what would be and this totally good. So again, voltage would be V1 plus V2. So V E air and D air plus E conductor and D conductor. So E conductor is how much? This is zero, right? Inside the conductor, it is zero. So we only have the air part, and that is how much? Sigma by epsilon naught and T minus T. This is V. So capacitance is again Q by V, which is Q by sigma by epsilon naught T minus T. So Q epsilon naught sigma is again Q by A T minus T. So Q will cancel, and capacitance would be how much? A epsilon naught T minus. So this would be the capacitance of a partially filled capacitor with conductor, not with dielectric. Dielectric one will have a different capacitance. So these are the different cases of the capacitor. Do you have any doubt?
No, sir.
Yes, any doubt? Okay, then please note down these thoughts. Down. And then we'll calculate the energy of a capacitor, parallel plate capacitor. Yeah, whenever you want me to scroll down, please tell me.
Yes, sir, done.
Then I'm
Yes, sir.
yes.
Sir, is it possible that we can end the class slightly early? I have 20 mark MCQ test on psychology chapter 2 tomorrow and chemistry classes on aldehyde, ketones, and carboxylic acids. And I have to submit my project and lab record also tomorrow. So
Oh, okay, so let's
I
say,
don't know why they're giving all of it in one day, sir. I don't know
yeah,
what they're thinking there.
yeah, that is totally pointless and nonsensical. But what we can do with the authority, right? Okay, cool. Yeah, so at 10 o'clock, we can. Yeah, after 7 minutes, that would be.
Thank you, sir.
Yeah, so no worries. Chemistry assignment, project, yeah, how many things in one day you are, all the things in one day.
Sir, I don't know like what's wrong with the teachers. Sir. Like last few days of school, they're still like telling to submit all the assignments and everything. I mean, I'm okay with the assignments, but they're
Yeah,
also
yeah,
giving tests on top of the assignments. The problem. I mean,
yeah. So that is piling up, right? Oh, yeah,
yes, sir. That's right.
yeah, yeah. So what we get, right? Whatever they are telling us at the end of the day, they have to
Yes, sir.
make.
Yes, sir. You can scroll down, sir. I'm done with
Yeah.
this part. Yes, sir. Done.
Done. Okay. I was seeing this meme that okay, so yeah, the next thing in 5 minutes. So the energy, the ultimate idea of the capacitor is what? Energy stored, right? So
Yes,
the
sir.
energy stored in parallel plate capacitor. So whenever I'm writing a capacitor, we just right. This is parallel plate capacitor. So we know that what is work done? That is Q, right? And what else do we know? That for a small work done, that would be how much? So this thing we have already understood, right? Work done is Q into V, right? So for a small work done, this would be how much? That would be dq and v, right? Because we are assuming that we are providing, right? So this v is there, right? Because for a small charge, we are calculating this, right? So we know that what is this voltage? What is this voltage? How much is the voltage? Q is CV. So V is Q by C,
Yes, sir.
right? And we
Yes,
will
sir.
write a variable one. So this is Q by C dQ, right? This is the small one. So now if we want to calculate the total work done, then I have to integrate this thing, right? And the total work done is the energy stored, right? So that we have seen that total work done is change in potential energy. So that will give you the energy stored. If we integrate this thing, so it get W, and this was just only to tell you that small work done for dq charge, right? So this is dW. And this capacitance is constant one, so we can take it outside. And what is this integral? What would be this thing from 0 to q? What would be this thing? What is the integral of x dx? Yeah, let me write it directly, and you think about how can we get this. This would be 1 by c q square by 2. Limit is q to 0, right? So this would be how much? This would be q square by 2c. So this would be equal to the energy stored, right? So energy of the capacitor would be how much? That would be q square by 2c. And let me write it as energy, because this is getting mixed up with the electric field. So this is energy. I will write it as U, right? So this is the potential energy or the energy stored in the capacitor. And yeah, yeah, so I will start from here, but you please write it down. I will stop here because you have to prepare all the other things. So stop here, and
Yes,
maybe
sir.
the next class will continue. Please annotate it
Thank you, sir.
down. Why? Why? Yeah, whenever you have put it down, please. Tell. me. So, yeah.
Yes, sir. Yes. Yes, sir. Done, done. Yes, sir. Done. Done. Yes, sir. Done. Done. Yes, sir. Done. Done. Yes, sir. Yes, sir. Done. Done. Yes, sir. Yes, sir. Done. Done. Yes, sir.
Okay, so all the best for your tomorrow's assignment and test, right?
Yes,
And
sir.
yeah, okay, so we'll uh, see you
Yes,
in
sir. Thank you,
the
sir.
see you in the optics class, right?